Now taking one another example, that is 255.255.192.0, then it becomes 0.0.63.255 and so on. In our example, in this example, we are using here /29 and here /8. So for /29, the subnet mask is 255.255.255.248, and for but here we are using /30 subnet mask because we are giving the subnet mask as 255.255.252. So we are using here /30 as a CIDR value. So for /30, the subnet mask is 255.255.255.252. So the wildcard mask becomes for /29, wildcard mask becomes 0.0.7, and for this the wildcard mask becomes 0.0.0.3. Here we use 252 because the CIDR is 30. So because of 252, the wildcard mask becomes 3. So the total wildcard mask becomes 0.0.0.3, and for /29, the wildcard mask becomes 0.0.0.7. So now let's configure the router. Here we need to use wildcard mask. So the subnet mask for this network is this. So the subnet mask is this. So the wildcard mask becomes this. So I'm giving the wildcard mask here. So the wildcard mask is 0.0.0, and you can see here wildcard mask is 7. So I'm using here .7. Press enter. Incomplete command. So this command is not completed, as in RIP we using only network and the subnet mask, but in OSPF we use wildcard mask instead of subnet, and here we use the area ID. Area, the set of OSPF area ID. So now for router 2, for this network belongs to area 0 because we use area 0 as whole. As I mentioned here, this is our whole area 0. This is our whole area 0. So here I am giving the area command, or area, that is area 0. You can find area ID as a decimal value. You can give this much area IDs in this particular iOS version. It depends on version to version. And you can give area ID in IP address formats also. So here I am giving a area ID 0 here. Press enter. Now this network is advertised. This particular network is advertised in OSPF with 29 CIDR value and in area 0. Now network command for different area or for different network, that is 10.255.255.80. Now for this network, TENS network, I am giving the command network 10.255.255.80 and the wildcard mask is 0.0.0.3. We need to give area here. This is also included in area 0, so I am giving area 0. Now you can check IP interface brief, show IP interface brief. Here the fast Ethernet is by 0 by 0. Configure this command, this IP, and loop back configured with this IP. Now apply OSPF for router 2 or R2. For configuring R2, just go to your interface configuration mode. Here need to give router OSPF. Now the process ID is 1, or you can change the process ID. Both routers may have the same ID or may have the different IDs. Now give the network command. The network is here 10.255.255.80 and the wildcard mask is 0.0.0.3. This is an incomplete command because we do not give area here. So we need to give area 0 here. Then the second network 192.168.10.48, then wildcard mask, that is 0.0.0.7, then area, that is 0. This is it for router R3. Go to configuration mode, just start OSPF process with the process ID. You can change process ID, it not matters because it is locally significant. It means it is a locally for this router only. Now give the network commands. Here the network is 10.255.255.8 and the wildcard mask is 0.0.0.3. Then the area is 0. Now we check the routing table. For R1, show IP route. You can see here this network is connected via fast Ethernet 0 by 0. This is our subnetted network. This network is subnetted and one subnets are connected via fast Ethernet 0 by 0. This is the network and this is subnetted. Two subnets and two marks are connected. The first subnet is this and the second subnet is this. You can see here. Here you can see 1110 is AD and 2 is matrix, that is connected via this interface, or you can say this interface. This is the interface ID and this is the IP address of that particular interface. It shows the O. O means the OSPF. This route comes from OSPF. Now for this router, show IP route. Here you can see these two are directly connected networks. Actually, you can see this router not getting this network. Let's check the problem. In this router, the routing done for this network and this network, but for R2 we need to routing for this network also. We done the routing for this network and we done the routing for this network. We forgot do the routing for this network. So we need to give a command for this network in OSPF on R2. So go to configuration mode, router, OSPF, just type the area ID just you used before. I am using 1, so here also I am using 1. Now the network command, now I giving the network ID, that is 10.255.255.8. the wildcard mask, that is 3, and it is the area ID is 0. Now you can check the routing table of this. Show IP route, and you can see here this network is coming via OSPF. That's AD is 1110 and the cost is 2. How it will get cost 2? Because this is the network. Here you can see this is the network is directly connected. This network is directly connected and this network is getting via OSPF with cost 2. This is the network. This is the first interface that cost is 1. This is the second interface that cost is 1. 1 plus 1 is equal to 2. 2 is the cost for whole path for this network to this router. So that's why here it shows 2 as a cost and 110 as a AD. This route is also coming from OSPF. This route also coming from OSPF because this is not directly connected network for this router, and this is also not directly connected network for this router. So here we can check the routing table for all the routers and we check the IP protocols command. Now the next command is show IP OSPF. Here you can check the number of this area is barebone area or area 0. The number of interfaces in this area is 2. Area has no authentication. SPF algorithm execute 6 times. How the SPF runs and how the authentication done, we will discuss about it in CCNP. The number of LSAs are 5. How we can check LSAs, we will discuss about it in CCNP. For CCNA, you can check here, this area is a backbone area. The number of interfaces in this area is 2. An area has no authentication. SPF runs for 6 times. The next command is show IP OSPF database. Here you can check for area 0, this is the router link status and this is a network link status. This means this is LSA 1, that is router LSA, and this is network LSA. In router LSA you can check, this is the network ID, this is the advertising router for this network or link ID. Age is 179. This is the countable number that is increase per second. This is the checksum and this is a sequence number. Checksum is used for security purpose and sequence number is used for sequencing the packets. This is a network LSA. This is in network LSA you will find network ID, this is, and the advertising router. The next command is show. These all commands are showing and checking the configuration of OSPF. Show IP OSPF interface FA 0/0. You can change the interface name. For this router you can check for router 2, that is this router. For this router you can check for FA 0/0 also, and you can check FA 0/1 also. Press enter. Here you will find network address is this with CIDR value, it belongs to area 0. The process ID is 1. Router ID is this. Network type is broadcast and the host is 1. The hello due in 5 seconds. You can check again. Hello due in 3 seconds. So this is a hello time that decrease per second. Hello is 10 by default and dead is 40 seconds. The DR address is this. The BDR address is this. You can check DR and BDR address by this command. The neighbor count is 1. You can check how many neighbors are connected and how many neighbors are adjacent. The adjacent neighbor count is also 1 in this case. So via this command you can check all of these things. The next command is show IP OSPF neighbors. Here the neighbor ID is this. This is the router ID of the neighbor. The priority is 1, status is full, and this is BDR. For checking, we are using this command on this router also. Show IP OSPF neighbor. Here you can see this is router ID that I am connected with. This is in full state and this is the DR. This is another neighbor ID that is DR. That is connected with this interface and that is connected with this interface. What is full? The full is a state. Actually, OSPF have some states that we will discuss about in CCNP. What are these stages are? For now, you can see this. OSPF have total 7 states. That the first state is down. In down state, OSPF is enabled but not received hello packet or hello messages from other side. The second state is init, or you can say initialization state. Got a hell in this state, in this interface state. Interface got a hello message but it not contain my router's ID in its header. The third one is two-way state. In this state, interface got a hello message which contains my router ID or the router ID same as I have. This is bidirectional communication is there. In this two-way state, routers becomes neighbors but they not become adjacent here. The next state is X start, or you can say exchange start. Master slave election is here. Master slave election is like this. These two routers are connected with each other. Which router is start to sending its update? So here the one router becomes master and master start, and master always start the sending the packets. After the X start, the exchange state is there. The link state information is shared in this state. Or you can say link state ID is exchange. Then the next state is loading. In this state, corrected link information is requested with the help of link state request message. Reply will come inside a link state update message. Then the state is full. Then the state is full. Database is synchronized in this state. These are 7 states available in OSPF. So here you can check. This neighbor is in full state. Now we are discuss about the next, or you can say the OSPF process between two or more areas. Till now we are discuss OSPF, or we are configure the OSPF for one area. Now we are discuss the OSPF for two different areas. We can use one more command here, that is clear command. We use this command in enable mode. Go to enable mode, just type clear IP OSPF process. By this command, we restart the OSPF process, or we can say we start OSPF process again from the beginning. Now reset all OSPF process. It prompt is show. Type enter. It means yes. Now the whole OSPF runs again from the beginning. Now go our point. Our point is configuring multiple areas scenario. For this, I'm using here this scenario. These are 4 routers. This is our area 0. This is area 1. And this is area 2. All other area like area 1 and area 2 is directly connected to area 0. So this is a scenario that we can use. Here I am using 12 or 12.0.0.0/8 network. Here I am using 14.0.0.0/8 network. Here I am using 13.0.0.0/8 network. Here is the loopback, that is 192.168.13.0/24. Here this router have a loopback that address is 192.168.14.0/24. Here the loopback is, and the address of loopback is 192.168.8.12.0/24. Let's configure it. Let's delete this and open the new Cisco packet tracer. Here our scenario is I'm using some routers here. I'm connecting these routers with a cable. I need to add some new port because this router having only 2 fast Ethernet ports. So I need to configure or add a port in this router.